Okay, today, guys, we're going to go over 8.2. It's on the quadratic formula. It's just something we have to know for college algebra. And if you go above college algebra, it's just something you have to know, to have in your toolbox of solving quadratics or solving equations. Let me get this saved in the right spot. There we go. Again, this Friday is going to be the final. It'll be open all day Friday from, I believe, 8 until midnight. I'm setting up the college algebra class. Once it's open, you can be. I'll open it up so you guys can go in there and check around and get the syllabus and look at the book that you'll need for the class. You can buy it online. It's pretty cheap. It's an older edition. He's already come out with the author has already come out with a newer edition. So if you buy it online, you can get it pretty cheap. Trying to think of what else. Other questions I've gotten. The best way to study for the test is to go back and look at your previous test. So the 6 regular tests are the best way to study for this final. It's going to be set up just like a regular test. You're going to go in, start it just through Blackboard. You'll get 2 hours instead of the regular hour and 15 minutes. You'll get 2 hours to complete it. And there's roughly 40 questions. I think there's a little less than 40. If you have any questions about that, just email me. I think that kind of covers it. Okay, let's get started. So 8.2, we're on quadratic equations. Very straightforward. Let me flip over. Before we even get there, I'm going to focus on really simplifying fractions, because students typically don't have a problem with the quadratic. You're going to be able to use the formula. It'll be simplifying it down into the correct answer. So let's look at first fractions that we're going to kind of get out of this. And then we're going to simplify them down. So really, I'm kind of starting at the end in a way, so we get comfortable with this. So what's going to happen is we're going to pop numbers into the quadratic formula, and it's going to crap out an answer. Okay, and the answer is going to look something like this. Let's say it was 4 plus or minus the square root of 20 over 10. Okay, something like that. And the thing is, you can't stop here. You have to keep going. And this is what people typically miss in this formula, is simplifying it completely, okay? So to simplify this thing completely, first off, you have to simplify the radical. We can't divide everything here by 2. The 20 is not a 2, okay? The 20 is a square root of 20. So we have to simplify first. So the very first thing when you simplify these, you have to simplify the radical. So I'm going to go over here to the left. I'm going to say 20 is 10 times 2, 5 times 2. I can pop out a 2. So it's going to be 4 plus or minus 2 square root, and I've got a 5 left over, all over 10. Okay, good. Now, what you're going to look at are the coefficients, 4, 2, and 10, and all 3 of them, not just 2 of them, all 3 of them. And you have to ask yourself, is something divisible into all 3 of these numbers? The 4, the 2, don't worry about the square root of 5, the 4, the 2, and the 10. Yeah, they're all divisible by 2, right? So I'm going to divide all of them by 2. 2 plus or minus the square root of 5 over 5, right? The 2 divided by 2 is just 1. You can write the 1 if you want. I am not, okay? And that would be our final answer. Now, look, you can write it as 2 separate answers, right? You can write it as 2 plus the square root of 5 over 5 and 2 minus the square root of 5 over 5. There's nothing wrong in that. And on the test, you might see the multiple choice answers written that way, okay? But because I'm going to be a little lazy today, just write them as plus or minus. And if we could add or subtract these together, we have to keep going. Let's look at an example like that. Let's say we had 1 plus or minus the square root of 4 over 3. Okay, so we pop it into our equation, craps out this answer, 1 plus or minus the square root of 4 over 3. Well, we can take the square root of 4. It's just 2 over 3. Well, look, now we can't add or subtract radicals together, irrationals and rationals, right? But we can add and subtract integers. So this winds up being 2 different answers, or 2 different, it's going to wind up being 2 different rational answers, actually. So we're going to do the 1 plus 2, that's 3, over 3. And 1 minus 2, that's negative 1 over 3. Well, negative 1/3, we can't keep going, but 3 over 3 is just 1. So that's our two answers for this example, okay? So we had 1 plus or minus the square root of 4 over 3. First, just like the one before, the first thing you're going to do, simplify the radical. And we get the 2. Now this one we can add and subtract. So we got to keep going. Okay, so let's do another one. Let's say we've got 6 plus or minus the square root of negative, let's do negative 9, over, let's do over 3. Okay, 6 plus or minus the square root of negative 9 over 3. Okay, well, look, I know our brains want to say 6 and 3 are divisible by 2, but again, we have to divide all 3 parts, okay, all 3 terms in this because we have the plus or minus. Now, again, just like the previous 2, we're going to simplify the radical first. Well, we know the square root of a negative is I, it's imaginary. So the square root of 9 is just 3. So we get 6 plus or minus 3i over 3. Now, look, we cannot add and subtract a real number and an imaginary number the same way we can't add and subtract an integer and an irrational, okay, or rational and irrational, okay? So we can't add these together. So at this point, or subtract, we're going to see if we can divide something into all 3 parts, and we can. 3, 6, and 3 are all divisible by 3, right? So we could write that as 2 plus or minus. Now, look, I'm going to just write the 1 this time over 1, right? If I divide 3 into all 3 parts, 6 divided by 3 is 2, 3 and 3 are both divisible by 3, that you get 1. Now, anything divided by 1 is itself, so you never leave 1 in the denominator. So this becomes 2 plus or minus I. So again, if you wanted to write it out, you don't have to, but it's 2 plus I and 2 minus I. Okay, but no. Okay, let me think of another one we might get. Okay, yeah. Another example we might get is, which kind of looks goofy, but it'll be like this. 3 plus or minus, hold on, let me start that over. 3 plus or minus the square root of 0 over 2, okay? 3 plus or minus the square root of 0 over 2. Well, look, if you add or subtract 0, square root of 0 is just 0, right? If you add or subtract 0, you wind up with 0. So this actually winds up with a 1 solution. And what really happens is you have a repeated solution. You actually have 2 answers because of the plus or minus 0. You have 3 halves twice, but we're just going to write it as 1 solution, okay? We're going to write it as 1 solution. So these are 4 good examples of really what this formula kind of craps out, and then what this what it simplifies into. And this is typically what students struggle with. Not the equation, not memorizing the formula. It's simplifying these down into their final answers, okay? Their final solutions. Okay, so let's look at the actual formula. So the formula looks like this. You guys have seen it before. If you have a squared plus b squared, oh my Lord, oh my gosh, it feels like a second Monday. Ax squared plus bx plus c equals 0. If you have an equation that looks like this, now the only rule really is that a cannot be 0. Okay, it can be anything but 0. We can do this. So the b and the x, the b and the c might be 0, but a, b, and c are all real numbers. So no imaginaries. A, b, and c have to be all real numbers, and a cannot be 0. It's got to be a real number. And if we have something set up in this manner, we can automatically solve for x. X equals negative b plus or minus the square root, b squared minus 4ac all over 2a. And some of you on the other side of this are watching, and you're kind of rehearsing, or you're remembering some jingle that your high school math teacher made you memorize. Typically, it's Pop Goes the Weasel. All over 2a, right? And if you're you don't know what I'm talking about, that's fine. But a lot of high school math teachers teach this to the tune of Pop Goes the Weasel. Okay, so let's look at putting solution, or to putting quadratic equations into this quadratic formula. Okay, so I'm going to steal an example from the book to start off with. Why not? We've got 3x squared plus 16x plus 5 equals 0. Here's a great example of when you can use this formula. The number in front of x squared is not 1, or it's not 0. So I know we can pop it in the formula. And 3, 16, and 5 are all real numbers. So I'm going to put it in here. So I'm going to write this out. Our a equals 3, our b equals 16, and our c equals 5. Okay, so let's put it into the formula. Negative b, so negative 16, plus or minus the square root, 16 squared minus 4 times a times c, all over 2 times a. And I'll tell you, some good habits to get into are putting a parentheses here and squaring whatever that b is, just in case it's negative. It'll remind you to put in the calculator as a parentheses squared, because if you put in like negative 16 squared in your calculator, it's going to tell you it's negative, some negative number. But if you remember the parentheses, it will correctly make this positive, okay? Now, what's underneath this radical is called the discriminant. Your book probably goes over that. Yeah, it's on page 603. I'm not worried that you know that, but I'll tell you, I like solving for the discriminant first so I don't rewrite things 4 or 5 times. So what I do on the side over here is I solve for whatever is under this radical. So I'm going to take the calculator, and I'm going to say 16 squared minus 4 times 3 times 5. And I wind up with 196. Okay, I think 196 has a square root. I'm going to write this out. So we get negative 16 plus or minus the square root of 196 all over 6. I'm going to take a square root of 196 just in case. Oh, it's 14. So this one has a nice square root. It's like that second or third example I did earlier. So I get negative 16 plus or minus 14 over 6. The square root of 196 is just 14. And now because it had a nice square root, I have to add and subtract the numbers in the numerator. So I'm going to, let's do this first one. Negative 16 plus 14 would be a negative 2 over 6. That winds up being negative 1/3, right? Negative 16 minus 14 would be negative 30 over 6, which is just negative 5. And there's our 2 solutions, negative 1/3 and negative 5. And they turned out being 2 nice solutions, 2 nice rational numbers, because we could take the square root. Okay, because we could take the square root, these wind up being nice, rational, integer over an integer numbers. Okay. So let's do another. Okay. So let's say we had 2x squared minus 4x equals 3. Okay, on this one, you have to have 0 on one side of the equation. I know I just balled up that piece of paper. But look, you've got to have 0. I didn't talk about this earlier. 0 has to be on one side of the equation. So descending order, x squared, x constant, and then a 0. Okay, your a is always in front of the x squared, b is always in front of the x, and then c is always the constant, okay? And you have to equal 0. It has to equal 0. So on this one, we've got equals 3. Well, we just move it over, and it manipulates it into how we want it. So 2x squared minus 4x minus 3 equals 0. So now I've got a equals 2, b equals negative 4, and c equals negative 3. So I'm going to divide this up so we can do another example over here on this side. So x equals, now look, it's negative b. Remember the equation, if you go back, it's x equals negative b. Well, if b is already negative, it turns it positive. Plus or minus the square root, b squared minus 4 times a times c, all 2a. Okay, and again, I like doing what's under the radical, the discriminant, to solve it out first. And again, this is why I use parentheses here, because if you pop this in your calculator without parentheses, your calculator is going to tell you that's negative 16 and not positive 16 because it knows order of operations, right? So let's find the discriminant first. We'd have 16 and then plus, 4 times 2 is 8 times 3 is 24. So we'd have 16 plus 24, which winds up being 40. So we get x equals 4 plus or minus the square root of 40 all over 4, right? 2 times 2, that gives me the 4. Now, look, I know our brains, right? We've got that pattern recognition skill. That's out of this world. And our brains see this 4 and this 4, maybe even the 40, and we want to divide it. Stop yourself from doing that. You've got to simplify the radical first, okay? We have to simplify the radical first. So the square root of 40, simplified, I'm going to do it up here. So 40 is 20 times 2, 10 times 2, 5 times 2. I can take a 2 out, okay? So I'll wind up with 4 plus or minus 2 square root of 5 times 2 is left over, so 10 over 4, okay? 4 plus or minus 2 square root of 10 over 4. And notice all three of these are divisible by 2, right? 4, 2, and 4 are all divisible by 2. So our final answer is going to, or two answers really, are going to be 4 plus or minus. That turns into a 1. So square root of, no, wait. I missed it. X equals, it's got to divide by 2, right? So we get 2 plus or minus the square root of 10 over 2. And I know your brain's probably red alerting you right now going, well, 2 divided by 2 is 1. But you have to divide it into all three parts. We can't divide a 2 into here, right? Now that 10 isn't a 10. It's a square root of 10. It's like 3 point something or another, okay? So we can't divide this by 2. Can't divide this one by 2 and the bottom, but because of this radical, not going to work, okay? So that's our two solutions, 2 plus the square root of 10 over 2 and 2 minus the square root of 10 over 2. Okay, another one here. Oh yeah, let's do one of these. I'm just, being pretty lazy today and just doing this straight from the homework or from the examples. But let's look at this one because it starts as a fraction, but it's easy to get fractions to go away with equations. So we've got 1/4. I'm going to make these y squared because I don't like writing m's minus y plus 1/2 equals 0. Now, I think we've talked about this trick before. Yeah, I know we have. Actually, if I want to get rid of, if I've got an equation and I want to get rid of fractions, look, this equation would, or this formula is going to be real wonky with fractions. So you don't have to put fractions in this ever, okay? You got 1/4 minus really 1y plus 1/2 equals 0. Or if you remember, the trick to get rid of fractions is multiplying everything in the equation. Look, there's 4 parts, right? 1, 2, 3, 4 parts. All 4 parts by the least common denominator. And the least common denominator, well, our denominators are 4 and 2, so the least common denominator would be 4. So I've got to multiply all 4 parts by 4. So I'm going to take out another color. I think this will show through. So 4, 4, 4, and 4. I multiplied all 4 parts by 4. And look, on this one, I'd get 4 times 4 is 4. Divided by 4, that leaves me with just 1y squared, okay? If you want to write the 1, there's nothing wrong with that. Negative 1 times 4, that's a negative 4y. And then 4 times 1/2, that's 2. And then anything times 0 is 0, okay? So we've got a equals 1, b equals negative 4, and c equals 2. And then I'm going to pop that into the equation and do what we've been doing. Look, right now, if you feel like you know what you're doing, I would pause this. Just click pause and then come back and see if you get the same answer I did. Okay. If you that way you can just kind of test to see where you're at. Hit pause, pause, and then come back. So let's say you just came back from hitting pause and you want to check your answer. Well, we're dealing with y, so y equals negative b, so it's a positive 4 plus or minus b squared minus 4 times a times c all over 2 times a. So again, I like finding what's under the radical. first. You don't have to. You can, I mean, well, you're going to have to because really it's the first step, but you can do this like all together if you wanted. 16, so it's a positive 16 minus 8, right? So we get a positive 8. So we get y equals 4 plus or minus the square root of 8 over 2. Do not divide everything by 2 yet. We cannot do that. That is not the 8. That's not an 8. It looks like an 8. It is not. It's some weird number like 2 point something or another, 2.9, I'm going to guess. I have no idea. You can pop in the calculator. It's not a nice number. I have to simplify it. So 8 turns out to be 2 times 2 times 2, right? So I can take a 2 out and leave a 2. So I wind up with 4 plus or minus 2 square root of 2 over 2. Now I can divide all three parts by 2. So I get 2 plus or minus the square root of 2. Now it's all divisible by 1. We just don't write it, right? If the 2 divides out on the bottom, we just don't write divided by 1. We talked about that on the first page if you want to go back and check that out. Okay, so those are our two answers, 2 plus or minus the square root of 2. Again, you might see it written like this on the test or in the homework, but no, it's the same exact thing. Okay, it's the same exact thing. Great. Okay, let's keep working on different examples. I mean, there's a lot of different ways these can kind of turn out. Okay, so let's do, this is a weird looking one. Let's say we've got P equals negative 3p squared minus 3. Okay, again, we have to have 0 on one side of the equation, right? I'm going to move, look, I want a positive p squared. I want a positive squared value. Negatives make the equation kind of goofy, and they make it harder to simplify. So to get rid of that, I'm going to, actually on this one, I'm going to move both of these to the other side. So I'm going to add 3p squared to both sides and the 3. Okay, so I'll wind up with 3p squared plus p plus 3 equals 0. So we get a equals 3, b equals 1 here, right? There's a 1, and c equals 3. So again, I would pause it right here. Pause and see if you can get this one right, okay? Okay, so now you're back from pausing. Let's see if we can get this one right. Let's see if we can simplify it completely. So we get p equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a, right? Now, under the radical this time, we get a 1 minus, well, 4 times 3 is 12 times 3 is 36, right? 1 minus 36, so we wind up with a negative 35. Hey, a negative, that means we're going to get imaginary numbers, okay? So we get p equals negative 1 plus or minus the square root of negative 35 all over 6. 35 doesn't simplify, right? 35, if you don't worry about the negative, the 35 is just 7 times 5. There's no pairs of prime numbers, so we can't take anything out of the 35, but we can, or we have to take the I out because it's negative. So we get negative 1 plus or minus I square root of 35 all over 6. Negative 1 plus or minus I square root of 35 all over 6. That's it. We can't go any further, right? There's nothing that divides into all three parts. There's nothing that divides into any of the three parts, okay? So we are done. That one was a little easier than we thought, or than I thought. Let me look at another example here. Okay, let's say we had, and I really do want you to hit pause on this one after I write it down. I want you to try it. Let's say we had 2x squared plus 20x plus 50 equals 0. Okay, so 2x squared plus 20x plus 50 equals 0. Hit pause. Okay, so now we're back. Let's see if we can solve this one out. A equals 2, b equals 20, c equals 50. If you saw that all three of these were divisible by 2, you're more than welcome to divide all three, or actually all 4 by 2. You will wind up with the same answer, okay? Yours are going to look a little different as we go along because our numbers are all multiples of 2s, but it's fine. We'll wind up with the same answer. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2a, right? Okay, so underneath this radical, I'm going to be lazy and just pop in my calculator. I get 20 squared minus 4 times 2 times 50. Oh, hey, I get 0. It's like that one example we talked about earlier. Negative 20 plus or minus the square root of 0 over 4. Hey, well, plus or minus 0 is the same number. Okay, if you add 0 or subtract 0 from something, you get the same exact number. So this winds up being negative 20 over 4. Well, negative 20 divided by 4 is just negative 5. Okay, so you wind up with negative 5. Kind of neat. Okay. I'm steal one from your homework here, guys. Oh yeah. Okay. Okay, let's look at this. This is number. This one looks weird. It's not that bad. Hold on. This is number 34 on page 608. I might need a little more room, but it'll be fine. So 34, I'll go over here if I need more. So 34, actually, let's start over here. 34 on 608. And it looks goofy to start with. It says x parentheses 7x plus 1 equals 2. Now, this does not look like a quadratic, right? It doesn't look anything like the ones we've been doing so far, where it's set up in this ax squared plus bx plus c equals 0 mode. But look, let's get rid of the parentheses. Let's clean it up a little, okay? Shower and shave and see if it looks anything like, oh yeah, look, move this 2 over now. Boom, we've got a nice quadratic. Right, subtract the 2 to the other side. We've got 7x squared plus x minus 2 equals 0. So again, so now we're going to start here. So hit pause again. See if you can run through this one and get the right answer. Okay, so a equals 7, b equals 1, and c equals 2 here, or negative 2. Be careful on that one. We wind up with x equals negative b plus or minus the square root b squared minus 4 times a. A is 7, not negative 2. That's a 7, guys. I know it doesn't look like one because I was rushing. All over 2 times a. So under the radical, again, I'm going to just pop this in the calculator. I'd get 1 squared minus 4 times 7 times negative 2. And I wind up with 57. I don't think 57. Is 57? Well, it's divisible by 3. Let's divide it by 3. It's 19 times 3. And both those are prime. They don't pair up. So I know I can't simplify the 57. So it winds up being x equals negative 1 plus or minus the square root of 57 all over 14. And that's it. I can't simplify this 57. It's not simplifiable with radicals. So therefore, because it's not simplifiable, it can't be simplified. We're done. That's it. Game over. Okay, that's number 30. Which one was it? 34. Yeah. Number 34. Okay. I'm trying to find ones that maybe have look different to start with, but they wind up being easier than you realize. Well, okay, 22. Yeah, let's do that. 22 looks kind of crazy. Do at least one more example now. So 22, we get 7p times p minus 2 plus 2 times p plus 4 equals 3. Okay, 7p times p minus 2 plus 2 times p plus 4 equals 3. Again, just like the previous one, it is not looking like a nice standard quadratic. So I'm going to multiply it, or get rid of the parentheses, right? Get rid of these parentheses and see if we can get it into something that does look like a standard quadratic. So 7p squared minus 14p plus 2p plus 8 equals 3. So we get 7p squared minus 12p plus 8 equals 3. Subtract the 3. We get 7p squared minus 12p plus 5 equals 0. Hey, now we had to do a little work, a little digging, but we got it into something that is a nice quadratic. Okay, 7p squared minus 12p plus 5 equals 0. Okay, so I'm going to actually not multiply this. I'm going to solve this one out. So p equals 12 plus or minus the square root negative 12 squared minus 4 times a times c all over 2 times a. Yeah. Now look, if you're getting the wrong answer from your discriminant each time, it's because you're not putting parentheses in your calculator, probably. I would write this, you could write this exactly like this in your calculator, okay? Parentheses, negative 12, close parentheses, square it. You might have to use that caret button, square it. Get out of the exponent, minus 4 times 7 times 5, okay? And it'll pop you into the right answer, okay? So if I do that, I wind up with negative 12 squared minus 4 times 7 times 5. Hey, we just get 4. I know the square root of 4. Over 14. Okay. 12 plus or minus the square root of 4 over 14. So I get 12 plus or minus 2 over 14. I can actually add and subtract the 2, right? Because we could take the square root. So I wind up with 14 over 4, which is just 1, and 10 over 14, right? Which is just 5/7. But that's my 2 answers. Awesome. Okay, so for homework in this section, this is on page 607. For homework, I want you to do, this is homework for 8.2. I want you to do 1 through 39 odd. 1 through 39 odd. Okay, 1 through 39 odd. Okay, now, just because I'm curious, I want you, if you watch this video and you get to the end, I want you to email me the word algebra. Email me the word algebra. And I'm going to tell you the first like 5 people that do this, I'll give a bonus point, 1 bonus point on the previous test. So the first 5 people that email me the word algebra from this class are going to get 1 bonus point on this next test. Don't tell. If you have a friend in here, don't tell them. I'm just curious to see who actually watches these videos, because I know my view count is not matching the number of students in here, which is fine. If you're doing well without me, that's not a big deal. That shows more about me than you probably. Okay, but email me the word algebra. I'll give you a bonus point on the last test. So anyway, I will see you guys tomorrow. So tomorrow we're going to go over 8.3, which is really a continuation of 8.2. And if you have any questions, please let me know. I will be here I'll be on campus for this week. And guys, remember next week we're going to have a week off, and then we'll start college algebra. The this week also, so the final again is Friday,